In this video, the procedure for the measurement of surface energy of substrate using Dyn test pens is explained with an example. Let's understand what is surface tension and surface energy. The term surface tension is associated with ink, and it remains constant. Note that the surface tension of Polydeuce Perfecta barcode ink is 23 Dyn. On the other hand, surface energy is a term associated with the substrate, and its value varies for different substrates. Since the surface energy varies for different substrates, we need to measure it to find its value. Since the surface tension of Poly-Tij Perfecta barcode ink is 23 Dyn, the surface tension of the substrate need to be at least 31 Dyn so that we get the minimum required difference of 8 Dyn between surface energy of substrate and surface tension of ink, which results for better adhesion. That is, for the substrate to be inkjet receptive, the difference between surface energy of the substrate and surface tension of the ink should be greater than or equal to 8. The test involves drawing a line on the nominated substrate with specifically designed pens which contains ink of a designated surface tension. If the liquid from the pen draw back into droplets in less than 1 second, then the surface energy of the substrate is lower than that of the liquid value. If the Dyn test fluid remains as a film for 3 seconds or more, then the material will have a minimum surface energy of that liquid value. The surface energy of the material can be estimated by the highest surface tension of the liquid in the Dyn test pen, which forms a continuous film for at least 3 seconds. Let's see it with an example. Here in this video, where a line is drawn with 30 Dyn pen, the Dyn test fluid remains as a film for more than 3 seconds, so repeat the process with increasing value of Dyn test pens. Now a line is drawn with 32 Dyn test pen. The Dyn test fluid remains as a film for more than 3 seconds, so repeat the process with increasing value of Dyn test pens. This time a line is drawn with 34 Dyn test pen. The Dyn test fluid remains as a film for more than 3 seconds, so repeat the process with increasing value of Dyn test pens. Now for a line is drawn with 36 Dyn test pen. The Dyn test liquid draw back into droplets in less than 1 second, so the surface energy of the substrate is less than 36 Dyn. From this we were able to determine that the surface energy of the substrate is 34 Dyn. If the surface energy of the substrate is less than 30 Dyn, then ink adhesion will be poor. If the surface energy of the substrate is higher than 30 Dyn, then higher will be the adhesion. Repeat this procedure to find the surface energy of other substrates.